Hi, everybody, and welcome to the Hive's Electroplater training sequence. Today, we're going to be covering how to set up an electroplated process, as well as how to actually use the electroplater to run that process. This video is going to assume that you've gone through and understand the standard two-layer unplated process first, so a lot of this introductory material with the protomat setup and drilling is going to be mostly perfunctory. With that being said, the first thing we're going to do is load the default template. Once the default template has been loaded, we're going to, as usual, go into the process planning wizard. That's the first button on the left. And as usual, we're going to be processing PCBs, double-sided material with FR4 as our substrate. And then we'll finally get to the first change from an unplated process, where we select what type of through-hole plating equipment we're going to use. Today we'll be going to be using the Contact S4, which is an RS-like galvanic electroplating semi-automatic system. The alternative is the LPKF Pro Conduct system, which is a more manual system that uses masks and a vacuum table to pull conductive material into very specific holes. The advantage of this is that you don't plate your entire board, and that's really important for RF and other high-frequency traces and designs where the thickness of the copper is really important. For today's process, we're not going to be talking about that Pro Conduct system at all. If you're interested, we have all of the chemicals and materials, and you can definitely send us an email about that. But we'll select the Contact RS box for now, and then hit Next to continue on to the next step. As usual, we're not going to be doing any surface finishing on this process, so we'll just hit Next to see a summary, and hit Finish to finish. We'll go next into the second button, the import step, and we'll start by importing our drills files. As always, we'll take a peek at the drill file itself and make sure that all the holes and the sizings look correct and that the import box is checked as expected. Under the layer templates for this plated process, we're going to choose the drill's plated layer rather than the drill's unplated layer. This will cause the drill hits to be done prior to the electroplating process so they can be plated. Sometimes you might have drill hits that need to be unplated as well. For that, you'll need to generate a second Gerber file for those drills, specifically import them and put them onto the drill's unplated layer. And that completes the two big differences between the unplated process and the plated process. That is, we have to check the box in the process planning wizard and add our drill file to the drill's plated layer. The remainder of this is going to be the same as the unplated process, and so we'll play through it quickly as to not waste too much time. And with that, we've reached the dismount material step where we'll remove the substrate from the protomat. Make sure to note the orientation. Marking the board probably won't help because there's a couple of cleaning processes during the electroplating process itself. Once you've done that, you can hit Next and step to the through-hole plating step in the protomat, which frankly doesn't do very much, but the software will pause here so that we can go and actually do complete the electroplating on the plater. So once we've removed our substrate from the protomat, we will leave the through-hole plating step up on the wizard and head on over to the plotter on the other side of the room. Holes look good, so we can get started with that. The electroplater is this boxy tool in the far corner here. The first thing to note is the location of the sink to the left, where you'll be doing a whole bunch of rinsing steps throughout the process. It's usually quite crowded, so make sure you clear out some space there before you do anything else. To the right of the tool are some accessories that we'll be using throughout the process as well. Underneath, you see a small oven that we'll also be using. You might also see the roll of yellowish tape, which is a chemically resistant masking tape and can be used to restrict the plating to specific areas. It's now located in the PCB tools drawer under the Sums kiosk. And finally, to the left are chemical-safe gloves and an apron that you'll be using for the final step, Bath 5. A brief note on safety: there are very few safeties built into this tool, which is important to understand as Bath 5 is a 97% sulfuric acid solution. The only thing the tool offers to protect you is a flimsy plastic bath cover, so it will require you to use the chemical-safe apron, gloves, and glasses when dealing with this bath. There are also absolutely no open-toed shoes allowed at this tool for any reason whatsoever, or even shoes that have holes in the toe like Crocs. It's really important for both your safety and the safety of everyone else around you that you follow these rules. If you're seen to be breaking either of these requirements, we'll have to have an unpleasant talk that may result in loss of privileges, so please don't forget. If you do get acid on yourself, even a small amount, there's a simple 3-step process to follow, which is shown on the wall on the left here. The first is to stop anything you're doing, which is hopefully pretty easy since you've got acid on you. The second is to wash for 15 minutes, even if it's a small amount. If it's an easy to wash area, you can definitely use the sink, but if not, like your eyes or you manage to get a whole bunch all over you, outside of the room, we have a chemical shower and an eye wash station. Please feel free to use this if you feel it is necessary. It's much more important that you don't get chemical burns than much of anything else. The final step is to get someone to call the Office of Environmental Health and Safety, or EH&S, and the Georgia Tech Police Department so that they can take a record of the incident. It's really important that you do these things, but if you forget, washing is probably the first thing you're going to want to do anyway, so you'll have a second to look at the other rules. So with all the boring but important safety details out of the way, we can move into actually using the tool. The first thing you're going to have to do with all of the PCB tools is log into Sums, which is done on the kiosk as normal, and which I've already done here. Next, you can lift the screen, though be aware that it falls back down pretty easily. And then, if the tool isn't already on, you can toggle the power button, which is located here on the right-hand side above the main power cable. The process steps are detailed one at a time on the screen, so we'll just follow along and press Next as we complete each step. Once the screen has actually started up, the first thing you're likely to see are a whole bunch of initialization warnings. You can just OK through all of these. Staff and the MPIs will handle anything that's actually important, and which will finally bring you to the first screen, which is preparing the PCB. All right, so the first step that we're going to do is we're going to be putting the PCB and the board into the holder itself. And you'll notice I'm not wearing any gloves for this because there are no gloves allowed on the screen whatsoever. You don't know what chemicals are on your gloves, so it's really important to take those gloves off. You can sanitize the screen beforehand so you're not touching anything. You can sanitize whatever you want, but please, no gloves on the screen. So we're going to take this board and we're going to grab our holder here. The holder is this tool. You're always going to want to put the design, your plating is going to want to be as low as possible in the solution because the plating bath is only going to go up about 3/4 of the way. And in this situation, I'm actually low on the plating solution, so it's only going to go up about this much. You also always want to put the board into landscape mode rather than portrait mode. And you're just going to slot it in here like this. There are 2 little slots there, and we're just going to slot this guy in. But that's not really quite enough because it's not really in there, it doesn't really hold. So there's this Allen key that's going to be right next to the tool, and this should never leave the plater. It should always be there. And we'll use that to tighten the tool holder, the board into the tool holder. And there's no need to wrench it down. You really only need it finger tight. The point is that it doesn't fall out when you pull the board out of the bath. So that's the first thing that we're going to do here. The next step is going to be the first rinse step. So now we have the substrate in the holder and you're going to grab this drip tray. The drip tray should always either live at the tool or at the sink in the drying rack if it's been used recently. You're always going to want to use this drip tray whenever you're transporting the substrate from the sink or to the sink back because you don't want any water or worse, any acid dripping all over the floor because this floor gets very slick when it's wet. So it's really important that you use the drip tray here. So I'm just going to grab the substrate and the holder and the drip tray and I'll walk over to the sink and rinse everything off. And what you're really doing with this rinse step is you're rinsing off any gunk or foreign material that might be on here before putting it in the first bath, because the first bath is a cleaner. It's basically like soap, but this is really about larger particles and whatnot, and the bath will actually remove any oil. But once we're done giving the board a once over, we'll come back to the tool and press next on the screen to continue. The timer that's displayed on the screen tells us that we're at a bathing step, and the phase number is the bath number that we're at. We're going to need to slot the substrate and the tool holder assembly into the appropriate bath, which in this case is bath 1. Each bath has an acrylic cover on it, which needs to be removed. Take care to let any condensation drip off back into the bath prior to removal, and then it can be slotted into the appropriate slot behind the tool. Notice there are 2 cover slots. The one on the left is narrow for baths 1, 2, and 3, and then the one on the right is for the wide top covering bath 5. The bath numbers are down here in front. It's important not to slot the narrow tops into the wide slot because we want to reduce cross-contamination as much as possible between the acid baths and the other solutions. On the underside of the tool holder, there are 2 sets of holes. The outer one are for thumb screws that are used for bath 5. The inner ones are the alignment holes, which fit into the pegs that are on the rails that lie along the front and rear of the baths. We can just slide the substrate into the bath and align the tool holders holes with the pegs, and you can bang it down a little bit. Sometimes it's a bit of a snug fit. Again, I'm not screwing the thumb screws down until bath 5, but just making sure it's snugly in place. And once it's slotted, I can then go ahead and hit the play button to start the timer. Once the bath 1 countdown has completed, you can go ahead and remove the board and the tool holder from the bath. Just kind of wiggle it up. Sometimes it gets a little bit stuck in there. Once you can remove it, let it drip drain a little bit into just all the excess liquid back into the bath. That way it just doesn't splash everywhere. And then because the next step is a rinse step, we're going to go and grab our drip tray here, put the board into the drip tray, and head on over to the sink to give it a good rinse. Once you're done giving both sides of the board a good rinsing, come back to the plater with the drip tray and hit next to reveal our next step to be a 5-minute timer for bath 2. Replace the lid of bath 1 first, and then repeat the process from bath 1 for bath 2. Let the cover drip drain back into the bath, and then slot it into the narrow slot on the left. Then insert the tool holder in with the substrate into bath 2 by aligning the pegs and banging down if needed. Once it's seated well, hit the play button on the screen to continue the countdown. At the end of the 5 minutes, as you just saw seen on the screen, it's another rinse step. So we'll go ahead and remove the tool holder and the board from bath 2, letting it drain a little bit back into the bath, just as we did for bath 1. And then once it's drained, we'll grab the drip tray here and move on over to the sink for a good rinse. For the next bath, bath 3, cross-contamination is a major reason for plating failure, so it's important to rinse both sides of the board well here. No need to scrub, just make sure to rinse all of both sides of the board. Once that's done, return to the plater with the drip tray, cover bath 2, and click next on the screen. The next step is asking to rinse in demineralized or deionized water. We don't carry that or use it by default, since it's mostly an issue for areas with hard tap water, but if you'd like to bring some, you're welcome to spray down your board. Click next when you're done. This brings up the timer for bath 3. Before you slot your substrate with the holder into the bath, it's strongly advised that you stir the bath for about 3 minutes, roughly 200 strokes from front to back, using the glass rod located either next to the tool or preferably taped to the bath 3 cover. Failure to do this is strongly correlated with incomplete or failed plating and a gigantic waste of your time, which is especially true since the plater is not used frequently at the Hive. And the chemicals tend to settle a lot, which means that they don't completely coat the material well. You'll want to be wearing gloves for all of the bath 3 steps, including and especially the stirring, because while the activator isn't dangerous, it will stain pretty much anything it comes in contact with, including your clothes and your skin. Disposable nitrile gloves are located to the right of the tool usually, or perhaps elsewhere in the room. I personally also like to wear the chemical apron to avoid wayward splashes from staining my clothing. Otherwise, the process is the same as all of the other baths. Lift the lid and let the condensation drain off before putting it into the narrow cover slot on the left. If there's excess water on your board, let it drain off into the drip tray before slowly sliding the board into the bath, making sure not to splash, and the holder onto the pegs. You can, again, kind of bang it down if necessary. This won't cause any additional splashing since everything's already in the bath. No need to screw it down again, but remember to take your gloves off prior to touching the screen, and then hit play to start the 15-minute timer. Once bath 3 countdown has finished, the next step, as displayed on the monitor, is to swipe the activator or ink from the PCB with a squeegee and dry it in an oven at a maximum of 50°C. The squeegee we're going to use for this is the blue plastic credit card shaped thing located to the right of the tool that looks like this. We'll use this to swipe off as much of the ink off the surface and back into the bath, so we'll unseat the board from the bath and hold it over while swiping. Don't forget to do the other side as well. The reason we do this has to do with the chemistry and physics of this type of electroplating, known as galvanic, which refers to the current that is produced by a chemical action. In this case, bath 5 holds a copper sulfate and sulfuric acid solution with 2 large bricks of copper. Once the tool holder and board are seated into the bath and the process is started, a large voltage is applied between the holder via the rail and peg assembly and the 2 copper anodes, which causes a current to flow. Free electrons are then ripped from the copper surface, causing copper ions to be released into solution. The electrons flow around the circuit onto the lower potential surface of the cathode, which is the PCB. The buildup of electrons there attract the positively charged copper ions that then settle onto the surface. However, the copper will only settle where electrons can live, meaning only on a conductive material, such as the copper. Because FR4 is non-conductive, this would not allow for plating inside of the holes. However, the activator is a carbon-laced conductive liquid that adheres really well to FR4. By soaking the board in the activator and then curing it, we create a conductive pathway for the copper ions to settle into the holes and other exposed FR4. This is why we swipe the excess activator off the surface. Copper is already conductive, and therefore we do not need, and actively, in fact, we don't want any of the activator on those copper surfaces. Once much of the excess activator has been swiped off of both sides and swiped back into the bath, we can use the Allen key to remove the substrate from the holder and place it onto either rack in the oven located below the tool. Make sure the temperature knob is set to 150 F, which is roughly 50°C, and then set the timer for between 10 to 15 minutes to actually start the curing process. With the board in the oven, we can continue on to the next steps. We don't use copper foil on our substrates, so we'll just go ahead and continue through this as well. This is bath 4. We don't use bath 4. It's primarily used for micro vias and blind and buried vias. We'll just continue and get to our next rinse step. When the oven is done, you can remove the substrate from the oven. Be careful, it's quite hot. Then you can go ahead and rinse the board. This rinse step is a little bit more important, so actually you should take a sponge and really make sure to get all of the extra activator off of the copper as much as possible. Doing so will make a much better plating job for you in the long term. So really get that activator off. And don't worry about rubbing it off from the edges or from the holes. The curing process really sets it in there nicely. Once you've done that, you can go ahead and reattach it to the tool holder using the Allen key, and then we can go ahead to the final step, which is going to be bath 5. The screen at this point will often show a number of warnings. As with at the first step, you can just OK through all of these and then get to the 2-hour timer that is bath 5. Once we're back at the tool, the first thing we're going to do is cover bath 3 if we haven't done that already. And then we're going to go ahead and put on the full set of chemical safety gear that we have at the Hive. The first step of this is going to be the chemical safe apron. It's located to your left. Just slip it on over your head and then tie it around the back of your waist. Once you've done that, we can go ahead and put on chemical-safe glasses. There should be some either next to the tool. There will also be a whole rack of them next to the 3D printers or next to the Sums kiosk as well. And finally, once I have my glasses on, I'm going to put on the big black chemical safe gloves, which are located to the left of the tool and look like this. Importantly, these cuffs must stay on at all times. It's really important because if you get some chemicals on your hands or your fingers and then you lift your hand up, the chemical is just going to drip down onto your elbow. And if you don't have the cuffs on, it'll really be a sad time for everybody involved. So keep the cuffs on at all times. Next, we can actually lift the lid here, making sure to let any condensation drip off back into the bath as usual, making sure that you obviously still have the gloves on. And then we'll slot it into the back, into the right slot there, the wider one. Click. And then we can take our tool holder and we can slowly lower it into the sulfuric acid, making sure to align the pins with the holes in the underside of the tool holder as usual. Unlike the other baths, it's really important for us to screw down the tool holder for this bath because on the underside of the holder there's a metal strip. And this metal strip is what passes the electrical current from the tool to the board for the galvanic plating to occur. But just placing it on top doesn't make a very good connection, so we need that because there's going to be about 30 amps of current passing through that junction. So we screw it in place to make a good solid electrical connection. And yes, it is a little bit difficult with the gloves on, but if you take them off, you're risking yourself and your hand with sulfuric acid, so we'll have to suffer through that one for now. And you don't have to wrench them down. Finger tight is totally fine. It's really just to make that good connection. But critically, after you've actually put this in and tightened it down, you can't be sure that the gloves didn't get any acid on them. So it's really important at this stage to go and rinse off the gloves before taking them off again, because again, there are no gloves allowed on the screen whatsoever, nitrile, acid, or otherwise. So we're going to go ahead and rinse those gloves off, and then we can take them off and actually start the process here. Once the hour is up, the tool will ask you to flip the board around before continuing, as seen on the screen. As we're working with Bath 5, you'll re-don all the chemical-safe gear, meaning the apron, the glasses, and then the gloves, prior to touching anything. Once that's completed, you're going to unscrew the thumb screws on the tool holder and carefully rotate the board 180 degrees. This rotation is attempting to create a more even layer of plated copper by trying to mitigate any effects due to variations between the two current pathways. It also helps to create a more repeatable process, which is critical for PCB design and fabrication. It is unfortunately a bit of a pain to unscrew the thumb screws with the gloves on, but again, these are for your own safety and the safety of those around you, so please don't take them off. If a PI sees you operating at this bath without the full chemical kit, we'll have to have a serious discussion that nobody wants and may result in loss of privileges. Once the screws are undone all the way, carefully remove the board and let it drain off a bit into the bath before rotating. A good method, as shown here, to eliminate stray drips is to lift the board up with the corner as the lowest point, let it drain from that corner, and then rotate such that the corner remains that lowest point. Slot the board back in once you've rotated it and screw it into place again. Once you've screwed it down into place, you'll go and rinse your gloves off and remove them, leave them to dry, press OK, and then hit the play button to complete the final hour of plating. All right, so now that the plating process is done, we see that the next step is going to be another rinse. And this one's going to be a little bit more of an interesting rinse step because our board is covered in 97% sulfuric acid. So we have to be pretty careful at this stage about rinsing. I also like to bring this Allen key over to the sink as well because I really want to remove the board from the holder and then rinse it, rather than rinsing the board attached to the holder. So I'll go put this over by the sink first, and since I'm already wearing the apron and glasses, I will don the chemical gloves before removing the board from the bath. Sometimes this takes a little bit of force to pull out, so be careful not to splash the liquid anywhere. Let it drip drain as usual, and then you can sit it in the drip tray while you cover the bath again to prevent potential contaminants from falling in. Next, we'll head over to the sink to rinse. Alright, so now that we're over at the sink with the full chemical kit still on, the first thing I'm going to do is remove the board from the holder using the Allen key. This will make our lives much easier because the sink is not large and usually there's a bunch of stuff all around it. I can turn on the water using my elbow, and then I'm going to rinse literally everything. Why everything? Because I don't know what might have acid on it, so it's safest to assume that everything is just covered in this stuff, even though that's likely not to actually be the case. It's not really that interesting to watch me rinse all of this, so we'll speed this up a little bit, but you can see that I'm literally rinsing everything, even the Allen key. Once rinsed, everything can be left to dry in the drying racks except for that Allen key, which should be put back next to the tool immediately so as not to get lost, and the board, which will need to be dried off in the oven immediately following the rinsing. The next and final step, as had been hinted at, is to dry it in an oven at a maximum of 50°C. The board should be dried as soon as possible after washing it, because water and copper don't mix very well. You can use paper towels if you'd like, or a heat gun, but the oven is the easiest option. Just slide the board in on top of the chemical-safe taped racks. Either one is fine. There's an internal fan, so running it for about 15 minutes at the 150 Fahrenheit setting is usually sufficient, though it's no problem if you feel the need to run it for longer or hotter. Congratulations, you've electroplated your board. The final steps, as always, are to clean up and log out. Make sure that all the accessories are back at the tool with the gloves to the left and the apron hung up. It's fine if they're not dry yet. Lower the screen and power down the tool by toggling the power switch located above the main power cable. And as always, the final step is to go to the kiosk and log out of the tool on sums. Once we're finished here, we can take the substrate back to the protomat and insert it as we removed it all those hours ago and continue processing as normal. The only additional difference is to select a plated material on the laser for the etching process when you get there. Good luck!